recording? Thank you. So today we are, first of all, let me say that if you did not catch last week, go ahead with your hand up, phone number ending in 502. I wonder if that was an error.
I think it's there. It's Nick.
Okay. Nick, stop messing with me. We went over the agenda somewhat and some of the expectations and that sort of a thing last week. So feel free to dive back into that if you haven't had a chance to look at it. If there's a YouTube link, you would have gotten it from Missy. You'll be reminded of it either over the weekend or on Tuesday next week with a link to this one to share around with folks that may not be able to be here. This is going to be a large event. We have on the order of 70 people traveling. More than 10 of those, I'd say between 10 and 15 of those are people that we loosely categorize as instructors or support people, including 2 people from my team, Matt Rantanen and several other folks. So there's a lot of folks that are there to be trained, although a lot of them also have a significant amount of experience. Everyone has experience that's relevant to be shared and learned from. So we don't really think of it as a big dividing line between trainers and instructors and attendees. But I'm pretty excited, and we're going to be trying to draw on the expertise of people in the room because we are going to have so many people there. I guess I should say, I'm Christopher Mitchell. I helped to run these events. It was kind of something that a few of us cooked up. Me, Matt, who was here last week, and then Spencer Sevilla, who is neither on the virtuals nor coming in person, unfortunately. But Spencer has been instrumental in helping us to come up with this idea and then execute on it. So we will unfortunately be lacking him in person. And the goal is to create a community where we are drawing on each other moving forward. So you're going to be meeting people. We have an agenda. We're going to be focused on learning a lot about fiber. We're going to talk about operations challenges. We're going to talk about digital equity. We are absolutely there to help people who are on the beginning end of this to get a better sense if you've got questions. One of the things that you'll get on the first day, I hope, is a booklet that looks like this. And we encourage you to check out the back of it, where we have a glossary and acronyms for people who are working a little bit harder on getting used to some of the technologies and things like that. So we are here to support people who don't feel totally confident in it yet. And we're also here to make sure that people who have been around and have more experience in it are able to share those experiences. So this is not a conference and will not be like a conference. It will be hopefully like nothing you've ever experienced, unless you've been to one of these before. So today we're going to be talking about some of the basics on how the internet works. We'll continue that. And we're going to talk a bit about fiber networks and planning for them and that sort of a thing. Our instruction will be led by Esther, who has played a vital role in every one of the Tribal Broadband Bootcamps and is going to be leading some of that discussion. And then Bob will also be leading more focused on the fiber aspects. But both of them are very open to just discussion. And I think we'll be able to pitch in and help each other out, as well as pulling things out of the chat. So if you have a question, even if you feel like it's a very basic question, you should feel free to put it in the chat. And if you feel nervous about that, then just send Missy a note and make her tell it and ask the question to people. So there's lots of ways to participate, but this will go really well if people have a chance to contribute in the chat and view this as a two-way conversation. So I think I'm turning it over to Esther first. Is that right, Esther?
Yes.
Excellent. So I am sorry that I have a commitment that I have to run away for, but leave it in Esther's very capable hands. Strongly encourage people to jump in and make it a participatory activity. And I'm looking forward to seeing you all next week. And then just a few days after that in person to break bread and get to know each other. So thank you all very much. And I'm going to listen for a little bit and then I'll just quietly poof, disappear.
Cool. I guess my first question is, and usually if I'm not
Sorry,
the one,
Esther, do you mind if I ask you to introduce yourself? And then Bob, when you go after Esther, just make sure to give a little introduction for people that weren't here last week. Thank you.
yes, so I'm Esther. I'm a PhD student in computer science at the University of Washington in Seattle. And I have been teaching for the boot camps for the past couple of years. I teach a lot about internet infrastructure, which is probably why I was recruited to do this. And so again, I'm using slides that I've taught with before. Hopefully you'll find it useful and it won't be too basic. But I would strongly encourage you to, if you have any questions at all, jump in. And I think usually what I do when someone else is leading teaching, for example, is I will take notes in a Google Doc and then make sure to make that available. And that can even be something that people can copy paste the chat into later. So I'm just wondering, would anyone be willing to do that? So yeah, I guess I wanted to point out first of all, that there is a folder. So there are a number of like digital infrastructure things that, we have access to for everyone who has ever been in the tribal boot camps. So like, for example, there's a boot camp resources folder that has all the material, like maybe not all, but most of the materials from other boot camps, including virtual sessions notes from other like rounds of the boot camp. And these are listed on the Discord for the tribal boot camp, which includes all of the or many of the former attendees as well. And so this is like part of the digital community building. If you are comfortable like using digital communications platforms to keep in touch with people, I think it would be a really great thing to, for example, join the Discord, get access to the Google Drive. So I'm going to, I guess, put the invite in the chat. So that's the Discord. And I guess for the notes, I can go ahead and just create a doc in that same folder, and I'll put it in, what is Discord? Discord is a communications platform, somewhat like Slack, which you might have seen before in other work contexts. Yeah, so let's see. Was anyone willing to take notes, or was that, I didn't see any volunteers, but basically the link is in there. Okay, great, Emma, thank you so much. Yeah, so, and this does like have a little bit of repeated material from some of the earlier virtual sessions from previous rounds of the boot camp. So if there's anything that you missed, or you're like, oh, I wish they'd talk more about this thing, you could check out the other virtual sessions notes in that same Google Drive folder. Yeah, cool. Great. And so without further ado, first of all, I would like to say, like, I'm very open to switching gears and like covering different material if you find that what I'm talking about is actually not useful to you. So I would like constant feedback. If like if you have any questions, don't feel free to jump in, but also if you're like, I would rather cover something else, like, can we hear more about this instead, then please feel free to jump in. Okay, so I guess I'm going to jump into because, you know, there's some stuff that we covered last time. I'm going to jump kind of into the middle of a deck that I used to, as Chris mentioned, like start out with a glossary. So one of the important things that, you know, we talked about in broadband work is the term access network. And so we're focusing on fiber networks in this coming boot camp, right? But like fiber is, you know, it can be one like method of creating an access network, one type of access network. You know, there are many types of terrestrial access networks. You can use coaxial cable rather than fiber, which we sometimes refer to as cable internet. There's DSL, you might have heard of that term, that goes over telephone lines, and both coaxial cable and telephone lines use electrical signals going through copper lines. And then on the other hand, fiber is light being sent as signals through glass. You can have bundled fiber going in a conduit, including like shared fiber, you know, that's owned by a number of organizations, maybe even municipal fiber, all these referring to, you know, who owns or like maybe has access to or uses this fiber. And you'll hear dark fiber. So that is, you know, commonly known as fiber that is not lit up with data. So it's like unused. There might be other uses of the term dark fiber in the industry. I'm actually not sure. Fiber to the home, you know, when you bring a fiber all the way to someone's house, or fiber to the premises if it's a different type of building. And, you know, the kind of traditional advantage of this, which we'll talk much more about in the bootcamp, is it's high bandwidth and low latency, versus there are also wireless access networks, including cellular. So that's not just Wi-Fi, you know, like 4G, 5G signals. Those are all wireless access networks. Yeah. And so this is just some terminology. Oh, sorry. I have, you know, pictures here, examples of each of these types of networks, which you might recognize from your home. And there's some example of fiber cable as well. Yeah, even satellite, you know, contrary to some popular belief, the internet does not all come from satellites, right? This is a belief that we encounter a lot when teaching about broadband. So satellite internet is like one example of an access network where you have a satellite dish that is receiving internet access from space. So that's like one type of access network, but it's very high delay going from the ground to space back to the ground, because there's a very large distance there that the data has to travel through the air. So that is a type of wireless access network, but we don't generally want to use it in our daily like internet access when we have other options. Another like typical, you know, term in the broadband world is backhaul. So actually, can someone, you know, well, yeah, I'll just go through it for the sake of time. Like backhaul is the term that we use. It's like more of a relative term. So it's whatever kind of connection connects the access network, which is like on the user side, back to a bigger network. And last time I talked about how the internet is the biggest global network. It's like a network of networks. And so you would consider your backhaul of your access network to be whatever's connecting the network that you are currently on back to another connection that will take you eventually up to the wider internet. And so you see how this is relative, because it's always relative to the network you are currently connected on. So each network has its backhaul until you get all the way back up to that core infrastructure at the internet exchange points. And I'll review that more in a bit, so you don't have to, you know, remember everything that happened last time. So I guess at this point, are there any questions about this initial terminology? And I'm not able to really see the chat. Okay, yeah, so it seems like there are no questions. Maybe this is too basic. So we'll move on to, you know, going a little bit more into how it all works. So I remember last time there were some people who said they were relative beginners to how the internet works as a whole. So yeah, I'll just start with kind of the high level overview of there'll again be some terminology, but basically how the internet works. And so we're trying to send some data, right? And we're using the internet, which is this giant global network, to send data. There are a number of things that we have to think about. First of all, we have to physically send the data. Like data is physical. It's always, you know, if it's stored data, it's going to be some bits residing on a computer, some like information that's stored on some disk. And then when it's sent as signals, you can think of those as radio waves. So they're waves of electromagnetism traveling in some format through a physical cable or physical signal. So how do we translate from that physical signal to a computer application and the other way around? So we're sending a message from computer A to computer B. Well, first of all, we've got bits, right? And so this is, you know, with my computer science hat on, like when you're just using the internet, you often don't have to think about bits, but let's think about them for a second. So a bit, right, is like the smallest base unit of information or data you can have. And so you can think of these as ones and zeros. And these ones and zeros are how computers store and read and interpret data. So you can like build up more complex alphabets from these binary choices. And so, like, for example, you would take an electrical signal, and that would have ones and zeros encoded as voltage, for example, an electrical signal. And so that, you know, a real signal is more messy than that. But basically that, like the ones and zeros get turned into numbers. And then, so you've encoded those physical signals as bits, digital bits. And this process is often referred to as modulation and demodulation, which is the process that your router will go through if it is a modem. If it's something that is, you know, you plug in physically to a cable and the physical signals are coming over that cable, and then that modem is encoding and decoding that information into bits. So finally, you go from the bits to your computer, your software. And so the software running on that computer will determine how it interprets, reads those bits and uses code to process them into some kind of application, such as a video call that's happening. And, you know, more terminology, you can think of these as what we call layers in the network stack. So, you know, in networking, you often have like different like engineering standards that define interfaces between these different types of like processing and handling of the signals that's going on. So on the hardware level, the hardware is going to process those physical signals, and then they get translated into bits. Usually on the firmware level, which is often like how you refer to the software of routers, essentially, that will handle like the bits. And there are many like protocols, or essentially kind of computer languages that operate on these different levels of processing. And then on the software level, that's when you've got data that is processed by computer applications. Yep, so that's kind of the conceptual diagram I would use to say that all of these stages or these layers are used when passing information across a network. So protocols are like language computers use to talk to each other at each layer. They include all the rules of communication between the computers. Right, and the protocols are often coded into, or typically coded into, the operating system of a computer. Okay, so, any questions at that point? Yes, I am still unable to see the chat, so please flag things for me.
Yeah, there's nothing in the chat right now.
Yeah.
Okay.
Yeah, I'm monitoring it too.
Okay, great. All right. Oh, yes. Sorry.
Hi. I'd like to go back to backhaul.
Okay, sure.
So we do have some of those, I guess those big
Microwave dishes.
towers. Yeah. So, but they're obsolete now. And now we have, of course, our host offices where everything's in there. So my understanding is that we can still use these at some point. And I'll have to, verify that. But I know that right now we were trying to decide, on getting them removed or what we were going to do with them because we don't use them anymore. But I guess just to solidify the answer in terms of what the backhaul for us means that now we're just moving everything from our host offices across our service area and taking out this part. Am I right with that? So each of the hosts are programmed for those specific areas for those who are getting phone and internet service. And then because this is out of rotation, we don't need it anymore. But do I understand correctly with it? That's how the service is coming through? Because we're also still on copper. We're not on fiber yet.
Mm-hmm. Well, so it seems like, well, sorry, you had said you've replaced these with fiber, with like a fiber, with a copper.
So for our company, we've inherited. The tribe bought it from the previous company. And so prior to us, these huge microwaves, I know of where one is. I don't know where the other one was situated or where it's at. But since then, they're obsolete. We don't use them. But I guess my question is there still use for them? If we program them or put them back into operation, can we still use them, or is it just best to no longer use them since we have everything within our host offices across our service area?
I mean, that's a good question. That's sort of like an operational question that involves like thinking about a lot of different factors. But so, I mean, just off the top of my head, right, is there any use for them? Whenever you have a backhaul link, like you can have multiple strategies for backhaul, including like failover. So have you used that term before, failover?
No, because I'm not I'm not in the tech aspect of our company. I'm very curious. So I started out, I used to work in public radio. So, those types of functions I was aware of. And then now moving to telecommunications, I was in customer service, but then I'm always trying to get more information based on the fact that, troubleshooting with customers, things like that, explaining it in layman's terms so they can get the gist of what's going on and trying to walk them through some of the issues so we don't have to do a truck roll. I'm just always constantly trying to educate myself in terms of what we're using, how we're using it. If there's things that are obsolete, how do we lay them to rest? Or, that's a huge structure that we have sitting out there. And I know that at one point that they were talking about disassembling it and moving it somewhere. I mean, I don't know whatever happened to that conversation. And now I'm into another position now where I'm just kind of like an operations manager. I'm here at the local site. I deal with everybody's department. So moving and following and tracking and following up with service orders and tickets and installs, things like that. But also things like this. I want to make sure that I'm understanding it clearly as well so that I can pass that information to other employees who, give the information out as well, and to understand it and to putting it into perspective so that we can make these better decisions on, a lot of this equipment that we inherited. If it's outdated, do we get rid of it? Things like that. is, I guess, kind of where I'm going to. I'm just kind of like spewing my brain out here.
So I see, I'm not able to see everyone, but I see that Bob and Sean had stuff to say. I just wanted to jump in briefly with, like, their towers are great assets, especially if you've had a link up for a while and, like, you know, the tower is in a good location. It can see like a large amount of your territory. Maybe it could be used to do like a wireless access network in addition to whatever access networks you've got. That can be helpful for emergency services. It can be helpful for just like any number of other applications. So before you, like, you know, put something away, put like a tower away, I would consider these other uses, like if it's worth the operational cost of keeping that up and maintaining it. So yeah, Bob, do you want to go first?
Yeah, you kind of already stole my thunder there, but yeah, the question is you might be able to use it differently, like as Esther was saying. You can use the towers differently. You're not knowing the wireless equipment you have up on your towers right now. You can't really say how you could use it differently, or it could be just keeping the towers and changing your wireless equipment. So definitely, they definitely do have use, or could continue to have use. This might be used differently. As Esther said, towers are a valuable asset. Your vertical assets are also very useful. And your question for backhaul, just to kind of restate a little bit what Esther was saying, how we normally look as backhaul is, our main road out, or our main path out of a local community to a bigger community. So it's kind of the consolidated path. So, you have your head end, you have your business office, and maybe you bring all your customers or all your service into there. Your backhaul would be that one big connection you have from there out to your provider. If you look at it in a phone system, it could be a single circuit from your phone switch to a tandem or something, and that's your that's your backhaul for your tandem or your phone service. So that's how we kind of look at it: is that what's your one true pipe that collects all your customers or all your business, and it's the one big connection out, or it could be two connections or what have you if you have redundancy. Hopefully that was helpful.
That was, thank you. It helps me look at the picture of, again, being resourceful because of where we're located in the desert, and miles away from where our fiber's coming in from on each ends of our service area. So making sure that we're being resourceful and being able to still put some of these things to use. I like the comments that I'm seeing in there. So it is good information. And I don't know if anybody else in my company is thinking outside the box, or are just seeing these things as obsolete when we could still be using them, again, for those fail-safe reasons. So I appreciate all the conversation and the answers. Thank you.
Sean, did you have something?
Yeah, no, it's just really just back at what you were saying. I mean, obviously, Chris and Matt can speak to this much more carefully or technically speaking. But, when you talk about the internet backbone, I mean, even when you're talking about wireless networks, it's still fiber all the way behind it. And so not knowing what, the layout of the land is there and where the fiber comes in, but fiber is driven into areas up to a certain point. And so those towers, the technology that is using, it sounds like DSL, you mentioned copper, is pretty much obsolete. But without knowing what those towers are connected to, I wouldn't be quick to get rid of them or anything like that, because depending on how far fiber is driven into that area, even if you don't end up doing that last mile fiber service, fiber to the home, fiber to the premises, and decide to go wireless, you still need fiber bringing it in terms of backhaul. And so so those towers could very well be in places that, if you're considering wireless access, those towers may be situated in the place that can help you down the line.
Yeah, I guess we will talk more about this probably at the boot camp, like how wireless and fiber can be combined. And whenever you usually, even as I'm myself studying like some fiber materials to prepare for this boot camp, because I'm still learning. And you always hear about how in certain situations, it is extremely difficult to roll fiber out because of something about the terrain or the sparsity of people. It's just going to be difficult, expensive. You might not have budget, equipment, whatever it is. And in that case, wireless can get you to that last mile in cases when you really need it. And so it's good to think about how you can use wireless in combination with fiber. So I guess I was asked to cover a little bit of like more basic IP addressing. Are we good to move on to that? I can't see the chat, so it'd be great if you could just like speak.
Yeah, I think
okay.
There's nothing in the chat right now.
All right, great. Okay, yeah, and please do let me know if this is too basic, or like basically if I don't get questions, then I'll assume everyone knows it. All right, so kind of getting back to how do computers send videos or any kind of data over the internet, including this video call we're on right now. Like this, I guess, this is going to be a very conceptual start with a conceptual high level overview. So there are these things called packets where, as I mentioned before, all data that's in a computer is ultimately stored as bits. So almost everything, like any item of data, like a photo, you can think of as a file, right? You store it as a file, and that file is encoded as bits, and that can be chunked up into different pieces. So that data is broken up into packets and mailed over the internet separately. Like you can think of the internet as just like a big mailing system that's always routing data in between different machines. So these packets are sent over the network. And this is particularly the internet as opposed to other different types of networks, right? So like, let's say if I were to have a plain old telephone call, just like a landline to landline phone call, that won't be broken up in the same way into these packets. But this is a kind of an architecture called, or it's like a design called packet routing, which specifically the internet uses. So the internet has its protocols that it uses that does packet routing. And so you can think of the packet as an envelope and its contents. The data or the payload goes inside and it has an address on it. And the whole internet system makes sure that your packet gets to the right address, the right computer on the other side. So this is, actually what a packet looks like. This is from Khan Academy. If you're interested in digging into the technical details of how each of these, how the fields are encoded, then you can do that. But yeah, I'm going to just go over a little bit of the routing side. A note on data sizes. 1 bit is a 0 or 1, as I mentioned. A byte is actually 8 bits. So if you are counting like bytes in terms of storage, like I have a 10 megabyte disk or like a USB drive or something, then that is actually counting in units of 8 bits. So it's like a little subtlety. So internet protocol addressing, or IP addresses, are the addresses on the internet. As I mentioned last time, they're kind of like internet real estate. So you've got your host or your home, address, the computer that is sending or receiving data. And each of these addresses looks like just a set of numbers. So this is an IP version 4 address. There are 2 versions of the internet protocol. So IPv4 and IPv6. Some of you may have heard of this distinction, but it's 2 different addressing schemes and they look different. So I'm first going to talk about IPv4 because it's simpler to look at and it's very common on the internet. It's still more common, I think, commonly in use on the internet than IPv6, but both are important. So I'm going to start with IPv4, and these addresses look like a set of 4 numbers separated by dots. You know, if I could see more of you, I would say, how many of you have seen one of these in your daily life? I'm not sure if I can, I can't really see people indicating yes or no, but I'm sure some of you have seen these. So every computer on the internet has one of these IP addresses. That's kind of part of what it means to be to have access to the internet. You need to have an address, and sometimes you can be sharing your address with many, many other devices, and we'll talk about that in a second. So each of these addresses, because the packets are stored in this like specific format that has a specific size, each of these addresses has to be a specific size in terms of data storage. And so each of these numbers ranges from 0 to 255. So it has 256 possible numbers. And that's because each of these fields between these dots is exactly 8 bits. So the whole space of possible IPv4 addresses is actually, you know, this first number can be 0 to 255. The second number can be 0 to 255. So it's 256 times 256 times 256 times 256 number of total existing IPv4 addresses. Does that make sense? I think many of you may have heard about this problem of IPv4 exhaustion. So basically, most of these IP addresses have been like purchased or allocated by ISPs, you know, various other entities. They've been distributed, and there are at this point more devices that want to be online than there are this combinations of numbers that make up these IP addresses. So that's like the problem here. We don't have enough IP addresses for the whole world. And that's part of why we switched to IPv6. So one of the things that is important in network configuration, or like, you know, setting up any kind of internet network, is having a plan for IP addressing. So, you know, how am I going to, like, what does my network look like in terms of what address it has? Does it share one address and then all of the other devices are like, for example, one main router that I have has one IP address, and all the other devices on that network are sharing that on the public internet. And there's this idea of having a subnet. So when, you know, whether it's like public IP addresses, or we'll talk a little bit about private IP addresses, like these network addresses are grouped into different groups called subnets that allow like one section of the IP space to be managed as like one cohesive network. So like just a subsection of that space. And so the way you define a subnet is by describing computers with like some of these numbers in this IP address the same. So this subnet would be described exactly by these 3 numbers: 172.16.254 something. And so there's this network. If I put a 0 in this last slot, that actually could be used to describe a network with 256 possible addresses, where you can vary each of the bits in this address and count, like from you know, 172.16.254.1, .2, .3, .4, all the way up to .255. So you're describing like a subsection of the total IP space that is of size 256. And I know, like, many of you may not even ever use this type of information. This is just kind of how the internet is structured. So, if you don't like get it at all, it is okay. But yeah, just on the high level, the part of the address that's fixed is kind of, I guess, like a zip code. It's used to narrow down where the address is. And then the section that's variable it describes like all the possible addresses within that subnet. And so there's this notation that you can use called CIDR notation. The acronym is like classless intradomain routing, but basically you can use this notation to define how many of these bits in these IP addresses are fixed. So what is, what are the numbers that describe all the computers on my local like sub network? So it can be a /24. That means that these 24 bits, these first 3 sections are fixed and the last section is variable, /16, even /8. And that means that the lower this number is, the bigger the network is, like the more possible addresses are in that subnet. And you can even have numbers like /23, which is where the first 23 bits are fixed and then that last one is variable. So that is also possible. You might have heard the term like masquerade. So when you set up your network settings, like even on your computer or your router, sometimes they'll ask for a mask. And this is just saying like we're pretending that we are putting a mask over all the bits and just reading the bits that are like, I guess, let through the mask. So we're covering up the bits. We don't care about these last, 9 bits in this IP address. So we're only going to let the first 23 pass through. And so the net mask, this set of 4 numbers gets translated into the numbers of the net mask, which also looks like the same format as an IP address. And this is all just having to do with how the bits are processed in the computer. Okay, so, that's a lot of technical stuff, but hopefully this can get you started a little bit understanding, like if I go into my home router settings, what are all these numbers? Like, how do I set this up? So this, we use CIDR notation a lot because when these different entities like Comcast, Verizon, AT&T, these internet service providers organize themselves and like route packets between each other in the internet exchange points, for these like data centers where all the routers connect together. They are all allocated different subnets of the total possible IP space. And so everyone knows exactly, what IP addresses they own, and they'll advertise these addresses to the other ISPs that they peer with over the border gateway protocol. So like, let's say my university, UW, is a customer of Comcast, then they get a smaller subset or a subnet within Comcast IP address space. And then each of these routers, right, they maybe they have, many ports that are connected to many different providers, like Comcast is connected to both Verizon and AT&T. So each of these routers has a routing table where it stores what IP address or like what set of IP addresses basically each port is connected to. And so that's how a router decides like where data is going. It'll look at the address and say, where do I have to send this block of addresses to? Yeah, and I guess finally, one of the things, like one of the solutions to the world running out of IP address space is something called network address translation. So there's this problem where we only have a total of 4 billion or so addresses, IPv4 addresses. So it's not enough And so instead of having each device in the world have a single public IP address, we're going to give each kind of local network an address, and then a router will figure out, all of the devices that are connected to it. It's kind of like when you have mail to an office in a building. So instead of having like me in my office have my own public address, we're going to have the building's mail system receive all the mail for me and then just forward it to me within that office that has an address. So it's as if my home router owns just like one IP address, and then each device on that will have an address on a private IP address subnet. So these are addresses that are not allowed to be globally routed. They're only allowed to be used for private uses. And so you use network address translation as a process that converts from a public IP to a private IP. And these are like the addresses that are treated as private on the internet. So if you ever try to send packets with these addresses publicly, then they'll just be dropped. The routers will say, oh, we can't route those, and then they'll never make it to their destination. And the major difference in IPv6 is that the addresses are much longer. So this is what an IPv6 address looks like. It's so much longer, and these numbers they have more bits in them, but also each of these digits here is actually a hexadecimal digit. So it can go from 0 to F, 0 to 9, and then A, B, C, D, E, F. And so if you see an address like this, it's IPv6. And currently we're trying to transition the whole internet to IPv6, but it isn't working that well because providers, aren't using IPv6. Like it's hard to transition. You have to migrate all of your equipment to equipment that that speaks IPv6, and a lot of providers are not doing this. So yeah, basically IPv6 does not need NAT at all, but there are a lot of issues where people using only IPv6 cannot access all other websites or all other computers on the internet because some networks or some websites don't even use IPv6. So these are just some examples of the protocols that are kind of running the whole internet. I guess in the interest of time, I will, I don't actually know. I think we have 30 minutes left. Is that right?
Yes, correct. We got about 3 minutes. Yeah. We end at 5:30.
Yeah, so I should probably turn it over to Bob, but this is IP addressing, and like the sort of bigger picture view is that the internet is constructed via all of these different protocols. So that includes the IP protocol that determines all of this addressing, and BGP, the Border Gateway Protocol. There's also something called the Dynamic Host Control Protocol, which happens to be how, like, for example, your home router would give out private IP addresses to all of the clients. So all of, your tablet, your home computer, your phones and everything, they would all get private IPs from the router using this protocol. You can also assign static IPs. These are some details about network configuration that you can get into if you're actually configuring networks. And there's address resolution protocol, which is interesting because it actually maps something you refer to as a hardware address on your device, which is like kind of a manufacturer burned number for each type of network hardware. So like, let's say, my phone has a Wi-Fi chip or like Wi-Fi card and a cellular modem, then each of those would have like a different hardware address, and the address resolution protocol actually negotiates like, hey, I have this hardware address, like what's the IP address of my router? And then it will negotiate getting an IP address so it can talk to other devices on the wider internet. And so there's this kind of bootstrapping that has to happen. And just as a fun example, this picture is a screenshot from a program called Wireshark that you can use to actually investigate the packets that are going through your networks that you have access to. I use this tool a lot. It's like the Swiss Army knife of networking. So you can just sniff packets and actually read the bits of those packets, read all the protocols that are happening, like what are all the computers saying to each other. So that's really cool, and I like it. Yeah, and there's like something called the domain name system, which actually it's the phone book of the internet. So it maps IP addresses to the actual host names, like Facebook. So java.com, espn.com, etc. So yeah, these are some of the protocols that make up the internet. I will turn it over to Bob. Sorry to take so much time.
Oh, that's okay. While you're stop sharing, yeah. So to quickly introduce myself, I'm Bob Sova. I'm Merit's VP of Infrastructure Strategy and Research. I've been at Merit for over 30 years. Kind of grew up building and operating networks. Not so much last mile, but middle mile, and we've been talking about backhaul. That's kind of what we do in the grand scheme. And I'm going to just talk a little bit about fiber infrastructure, how to get started, kind of a high level. It's not going to get into a lot of details, but just, how to get started. Let's see. Share.
Sorry to interrupt. I was just wondering, Esther, there was questions in the chat. I didn't know if you were able to address those. Sorry, just didn't know what was going on.
Go ahead and answer the question.
Oh, sorry. There were many questions in the chat. I will let Bob go first. And meanwhile, I think maybe we can address those either in the notes or in the next session if there isn't time this section. Yeah. Okay,
so very quickly, I'm going to talk a little bit about how to get started with a fiber plan. And doing your engineering, construction, and operations of owning, a fiber infrastructure. One of the most critical things that I feel, this is a lot of lessons learned from my years of experience. Really getting started is you really want to know what your project why is. Why are you doing it? Why you want to build fiber and where and when. Then you can define your project, understanding your why. And that really helps it when you're seeking, funding, collaborators, partners, or other organizations to work with you, and understanding. And then also if you go and seeking grants, Merit has built a lot of infrastructure with grant money. Really understanding your funding resource, source requirements. When you're working with the federal government, they have a lot of different requirements that you need to understand at the head end, at the beginning of your project. So make sure you can account the resources you need to make it all happen. So once you define your project and you get your funding. There's a lot of stuff right ahead of before you do one thing, before you put one thing in the ground. But understanding how you select your vendors and your contractors, understanding, your requirements, your construction requirements, understand what you got to do for your permitting. And then, but also understand what do you want to do between, aerial and underground, and I'm going to be talking about quite a bit of that, for a little bit of time that we have here. But these are really the kind of the steps you have at a fiber project, is all these, from selecting your vendors to what do you mean by construction closeout and where you're at on that. But getting started, depending on the requirements that you have with your funding resource and also where you're building, you'll have a lot of different things that you'll have to do, and doing a do you need to do an RFP or do an RFI? What does that mean? What are the requirements within that? You need to decide. Also, do you want to combine your engineering, construction, and materials all in one project, one RFP, or do you want to break them out into different pieces? And we've done it both ways. Personally, I like doing it where we select our engineering firm, we select our materials firm, we select our construction firm, so that we have more control of what's going on. But we've also done it where we've selected one vendor and say, you do it all and tell us when it's done. So it all depends on what you feel comfortable in and doing. But that's something that's a decision that you really need to make early on. And if you're going to be doing a project and what you're comfortable with and your experience and who you have with your on your team. With each component, you definitely want to develop a criteria matrix where you know how you're going to measure any of the respondents or understand how you're going to look at the project. That's important for yourself, and it's also important for the vendors that may be responding to your project. And last but not least, actually, it's probably one of the most important thing. Any project is decide how you're going to do project management. Are you gonna have project managers in your within your organization, or you contracted out? Again, with all these different projects, project management is so critical in making sure you're getting things to do, getting things done the way you need to get done and staying on schedule, and also staying within budget. The other big challenge is early on, and I do this all the time, even before we even get the funding, I start reaching out to to the permitting agencies where we may be building or where we're planning to do a build, just to see what challenges we may make friends with them, get them to buy in on the project and why it's important for your community, and understand where what their needs are before you even start throwing out permits at them. I found that's the best way of understanding where you got to go and what you need to do, especially in environmentally sensitive areas and also historical areas. Working with your tribal historic preservation officer or your environmental officers, it really is critical that you have early and often engagement just to make sure your assumptions and your project and your contractor's assumptions are aligned with what the requirements are going to be. And please, I'm not seeing any questions because we're not able to see chat. So someone just yell at me if you have any questions. See what we got time. Okay, so there's also two main ways of doing construction on for fiber infrastructure. You can build underground. You put your infrastructure underground, or you can attach it to utility poles, and we call that aerial. There is pros and cons with both. Quite frankly, when you look at underground, it's typically more expensive to build per foot. But my experience, it does shorten up the time to deliver. And the reason is when you're planning on doing a build and you're attaching to utility poles, well, you need to engineer to the specs of the utility owner. And sometimes that requires a lot of additional engineering, a lot of maybe what they call make ready is, this pole is not big enough, or or there's not enough space, so we have to replace the pole, or we have to move other entities on the pole. So that extends the time to deliver, because the utilities want to make sure things are done correctly and safely for the public safety, and also the safety of what the service they deliver, which is typically very important power. So so a lot of times my experience is it does ends up shortening the time to deliver by going underground, because you have more control. The construction, the underground construction does take longer, but you usually can start earlier, because you get your permits a little bit sooner and quicker. Also, underground typically is less an operating area. Especially, and I was just looking at this earlier this week with the inflation and the cost of everything. We're seeing when you're on utility poles, you pay what they call pole attachment fees, and a lot of those fees are based on cost of living, and they have to start out with a base rate, and then it goes up. And over the past about 7 years, our pole attachment fees from one company has more than doubled. And when you're on tens of thousands of poles, that's pretty significant. So you're already paying a cost of being up on poles, the pole attachment fees, and those fees continue to go up. Also, we find there's a lot more events on that you need to do for repairs when you're aerial. You get your squirrel chews, you get people running into utility poles, you get trees coming down on the power, on the infrastructure. Also, in some areas, you have forest fires and stuff that totally destroy the utility, and your cable. So typically, operating costs, once you get to stuff underground and safe, your operating cost is much less, but it is typically a little bit more expensive per foot to install. So these are the things you want to look at. I always recommend or talk to folks that if you're how am I doing time? Okay, when you're if you're seeking a grant, or you're doing something that you're going to get federal dollars or local dollars, and it's a one-time, you might want to really think about actually do stuff underground, because if you're responsible for the OpEx afterwards, you want to lower those costs as much as possible, because you can pass those savings on to your community, the folks that you sell service to. So these are things you need to look at. But I will say with aerial, I see this typically for last mile providers. Like I said earlier, that we're more seen as a middle mile infrastructure organization, because our prime membership, our prime base of customers are universities, K-12 schools, private colleges, anchor institutions, government, private or governmental agencies. So we don't have a lot of drops. We just have few customers. But if you're providing services to homes, there might be a combination where you might want to say, well, we want our core, what we talked about earlier, the backhaul circuits, or the backhaul path where there's not a lot of drops. You might want to put that underground, but for your local access in the homes, it might be easier to go aerial that way, because you're up there and you can access your fibers easier and get into the homes. It all depends on the density, how much you have to access your fiber and things like that. These are all things you got to balance out. So there's not just one answer between going aerial and underground, but there's a lot of things to think about and consider as you make your decisions. And my recommendation, and every area is different. California, I've talked to a lot of folks out in California, and they have the fires out there. That's a big, that's a challenge of being aerial. Well, then, we have northern Michigan, where we have in the UP, we have this, I claim it's just one rock, but we have this, rock shelf that is, only about 2 or 3 inches underneath the dirt. and it's very hard to do any kind of construction, putting stuff underground because it's granite or it's real hard rock. So you got to also look at the terrain and things as you make those decisions. So, a good engineering firm, talk to other folks that have done builds in your area that know about things to kind of help you make those decisions. Here's just some pictures I got on the left here. That's what we call an underground vibrating plow rig, where you have a conduit that you're putting in the ground, and then you blow the fiber in that, and it's basically just a plow that lays that conduit about 48 inches in the ground, and then and you can see there's very little distortion. You see a little bit of path on that stuff. So for underground construction, underground plow with a vibrating plow, that's the most economical way of doing underground. Boring directional bore, which is the picture on the right, that is that is something where what they do is we have a drill bit, drill head on the end of that rod that you see going into the ground, and they just continue to push that underground to a certain point further down the road, a few hundred feet. It pops out. They change the head to a pull head where they connect the conduit to it, and then they just start pulling those rods back out, and then that's how you get that conduit underground. Boring is typically done when you're in activity where running a plower would destroy curbs or sidewalks or driveways, concrete driveways, or things that you really can't run the stuff that's on the left. And it is a little bit more expensive. With aerial, like I said, you need to do the attachments on the poles and stuff, and everything's out in exposure C, and it also takes a lot of work afterwards, after construction, of measuring your pole heights. That middle picture is actually a staff member that is using what they call a hasting sticks, and it's a giant ruler basically, and we measure where the fiber is off the ground, to the ground, to make sure we have clearance, and that's a very important aspect of knowing how high you are, because you got to make sure you're high enough where your stuff doesn't get hit. Again, I just want to demonstrate that sometimes you got to do work in the wintertime. So this is just another plow, a little bit heavier plow that's going through in the wintertime. And this one here, because it was so rough and stuff, that we actually had a bulldozer in front of this rig to help pull it. Oh, there's a picture of that. So also in the hard rock areas, you can do a rock saw, which this is one of the more expensive per foot methods. And what you do is you cut a trench and then lay the conduit in afterwards. So, and as you can imagine, that's a pretty impressive operation to do. We've got very few minutes. So at the end, there's also a lot of work once you get done. Acceptance testing. I can't stress this more. You should always have folks out inspecting as work is being done. Making sure that they're hitting your requirements, hitting the construction requirements, permitting requirements. I recommend that you should have an outside firm or someone on your team or a trusted third party doing your inspections. Just don't trust your contractor that you might be hiring. Things you got to check, like I said, you got to check your pole attachment heights, your midspan heights, ground depths, splice casing, placement, and make sure that everything's grounded correctly, where your maintenance loops are, and also anchors and other things. You really want to make sure when you're done that it's done right. And I found that contractors like to try to be as fast as they can, and sometimes they take shortcuts. So you got to have that commitment. We are going to make sure we have people out there independent to take a look and make sure folks are doing the right thing. Also, make sure you take pictures, test your fiber, make sure make sure you get your fiber test specs using an OTDR, which is optical time to main reflectometer. And what that does, it sends a light pulse out the fiber, and it has the reflections coming back, and it can measure where where splices are at, where there may be problems with the fiber, all this stuff, and gives you those details on a per fiber basis. And that's really important to have that information, because your equipment that you're going to be using to light your fiber, it has specs that your fiber has to maintain. So, and it, make sure things, is spliced correctly, make sure, things in the splice cases are correct. You have, sometimes you get a micro bend or something, and you could have a, impact on your fiber. And actually, hopefully, Nick, if you're listening, maybe you can show at the boot camp. Unfortunately, I can't be there. Bend some fiber and with an OTDR and show people how, or you're using a power and show how it makes a difference when you have micro bends in the fiber, stuff like that, to kind of demo on the importance of having things right. We always do samples of underground depths and things like that too. Just really maybe do well on your inspection. Make sure you get accurate final drawings that you can use for the future. And I don't know if I can stress that more than anything, because when your engineering firm will create a engineering drawing that your construction company will use to do the construction, and then they'll do what they call a red line, which is no matter what you design, there's going to be subtle changes and stuff in the field that needs to be done, and those are called red lines. And then you take those red lines back to your engineering firm, and then they provide a final CAD drawing for you, and that information is going to be critical for you for moving forward and maintaining your infrastructure, because that's going to be your baseline of what you have and where it's at, and what your infrastructure looks like or should look like. While operating, I said we don't have a lot of time left. So outside plant management is another big challenge.
Oh, hey, Bob, I think am I correct in assuming that people are okay with Bob just finishing out the slides as even if we go a few minutes over?
Yeah, I think the majority is, and people that need to jump, feel free to jump though too, and we'll capture this on the recording, but those that want to stand by, we'll go through the remaining part of the slides if you have time.
Yeah, I just have a couple more slides. I'll try to be prompt. Sorry. So let me go back. So in operating, there's a lot of outside plant management that you'll have to maintain. You have to have a good team to be able to have the tools to maintain your infrastructure. You have to continue to maintain your pole attachments, your right-of-way permits, and also really importantly, make sure that you're doing your locates. One of the big mistakes I think a lot of, at least I see with municipal entities, they say, well, we're in our right-of-way. We know who's in our right-of-way. We don't have to locate our stuff. Well, I'm going to tell you, there's always going to be someone out there, a farmer or someone with a backhoe or with a thing that they set and call in. They call in MISDIG. They call in the locate services. You're not locating your stuff. They say, "Oh, I'm killing a dig right here," and then your stuff gets dug up. So it's critically important that you maintain a good business and locating your infrastructure, make sure others locate. And when anyone's doing shovel work, make sure they know where your stuff's at.
Hey, Bob, I have a question.
Sure.
So in terms of us pursuing this fiber switch from copper, the talks that I've heard is, and this is where I'm thinking of the fiber locate. I mean the locate. The talk that I've heard is that they're going to just go side by side. And so alongside of where the copper is current and laying in fiber next to it. And then for us also, because of the terrain, we will be going both aerial and underground. Do you have any thoughts on that, or?
Well, and going aerial and underground, or laying your...
Yeah, both. Well, going alongside.
Yeah, going alongside. There's some risk there because you might think you're alongside, and over time, because stuff gets, things shift, you might shift out of the safety zone of your locate. So I would be, I don't know if I would be comfortable just relying on something right next to me to do for my locating. So I mean, just personally, because I know just, how close these contractors, dig to their, to the barrier and stuff, I would recommend, because if you're going, put it this way, if you're going to be, you're going to be going alongside your current copper, and when someone calls in a locate ticket, you're going to be locating your copper. Why not make sure you locate, have them locate your fiber too at the same time to make sure you're covered. That's what I would recommend.
Correct. And then some of that copper, I guess, is what they're thinking is that it's going to become obsolete. And again, this is just new to us, and I'm just trying to gain the most information that I can pass along of things that they may not be thinking of. Also for the fact that everything shifts so dramatically out here. It's, sand and mud. And so, I mean, even now they can locate, cable, and then they say it's located, and then whoever's asking for it, they end up cutting it. So it's just like, is this really a smart idea, or should we be looking at a different view of how we're going to put this together?
So, and also while you're especially since you're going aerial, my assumption is you're going to use armored cable that helps protect stuff, and that's a metal thing. So you don't have to put a secondary locate wire in with your fiber. If you're using armored cable, that's metal. You can use that armored sheath as your locating wire, and that is surrounding your fiber, so it's with your fiber because it's part of the fiber sheath. So I would, that would be my recommendation is, especially like you say, the copper may go away later on, or, stuff. I would, personally, if it was my infrastructure, I would go with armored cable, aerial and underground, and do the locating on your fiber that's underground.
Yeah, there's just areas that culturally, we live on top of mesas. So for those areas, we're not allowed to cut through the rock up on top of those mesas due to cultural preservation. So for those areas, we do serve them aerially. And so for those areas, we wouldn't be, again, digging and putting fiber in underground. So that would be the same thing. But could you provide your contact information, and possibly would be willing to have a talking table with maybe our techs if they have further questions? Perfect.
And actually, the real expert is Nick Andrews too, who's on the call. That's going to be he's going to be at the boot camp this time around. So we're going to talk like that. But yeah, I think my contact information is all part of the stuff. But I'll put, when we get done here, when I stop sharing, I'll put it in chat.
I appreciate it. Thank you.
Okay, so operationally, getting back to for underground, locate. Make sure your infrastructure is grounded appropriately. Check, do periodic check on your grounding. You don't have to check every site, but every grounding location. But you should keep an eye on it. You should always do a annual write out to take a look at your infrastructure. Things change, and like I say, it could be a little bit different in every area. Here in Michigan for aerial, especially aerial, we have a lot of trees, so we need to keep an eye on you know, the tree growth, is it interfering? Is it going to be a problem if a tree goes down and stuff? So we really keep an eye on those type of things. We also keep an eye if you have aerial stuff lashing. That's what keeps your fiber, you know, up on the messenger wire. You want to make sure, you know, your messenger wire or your lashing wire, excuse me, is in good order. You know, that you can see it when it starts fraying and starts coming apart. All these things are really important because it's much easier to go and repair your lashing wire while your fiber is still hanging. Maybe it's just gapped. I've reported this like 3 or 4 times on, you know, down by where I live with the local provider. You see a gap between their messenger wire and the fiber because the lashing's gone down. You know, it's like 2 or 3 inches. It's going to be on the ground pretty soon. And if they fix it now, there's no outage, there's very low cost. They let that all totally unravel and lay on the ground. Who knows what's going to cost? So, you know, that's why it's really important to perform doing your inspections. Always, you know, really stay on top of your infrastructure. Keep it good. And also, you know, with the underground, with locating, we just was talking about that. You know, there's a couple schools of thought, and it all depends on what you want to do with your crew. You know, you could have your own organization do the locating, or you know, there's national or local service providers that do locating. So you need to make sure you know, figure out what you want to do. But you know, I can't stress enough on that. Also, what I would also recommend that's not on this list on operations is, you know, your splice cases are very important. And what we do is we really restrict who can get in our splice cases and work on our fiber, because that piece is really critical. That's where your fiber can be exposed, can be damaged, can be not done correctly. And so really think long and hard of who you're going to have maintaining your infrastructure, and also you know, how much you want to restrict that, or who can actually touch your infrastructure. So that's it for my slides. Let me stop the share. So any questions? Oh, I see a bunch of stuff. Oh, Missy's already shared my stuff. Okay. Living in signs where your fiber is located. Okay. So Bob, does that mean? So yeah. So this is Esther's question on putting signs or labels. So yeah, you should always tag your fiber. There's some standard, and if you're in the aerial, if you're doing aerial, you know, some utilities have certain requirements of what your tag can look like. Here in Michigan, we have a provider where if we're you know, we're seen as a higher ed education entity, so our tags are, in some areas they're orange, in other areas they're blue, because they want to identify us, you know, from the road, you know, from driving out that we're education, or we're education based. So always, you know, make sure you put your tags in, because that's really important. You know, having tags on your aerial fiber and also on your underground fiber, and having your locate post and your marker post with your name on it. I tell you, it's more than helpful, because we you know, the public sees something, they see our fiber hanging, they see something gone awry, they contact us, you know, and say, hey, do you know that this is going on? So we can get out there, you know, when we're not in our, you know, normal route of being at a location. So it's critically important to have the appropriate tagging and stuff. And most pole owners and stuff have some specs on you know, what is the appropriate way of doing your you know, tagging.
You also had a question about clearances above. Let's see.
Yeah.
Who had
So
that?
Yeah. So that for the aerial, so there's a lot of different requirements for aerial, you know, attachments. there's one kind of overarching one, which is the National Electric Safety Code, NESC. There's requirements where you can't have your contact your fiber within I think the standard is 40 inches of any power source. So any pole, so you have to have that gap from power lines down to your cable, and then also there's requirements for ground clearance, and again, some of it is a national code and some of it is local. Railroad, some railroads have a requirement that you have to have 23 feet, 24 feet. Others only 22 feet of the midspan or the lowest point of your cable or railroads. Your state Department of Transportation may have a different clearance standard than local county or municipal standards. So you got to look at all those things on what your clearance. We're in Michigan, so we have to also measure or predict heavy ice loading. And believe it or not, you see a span, most of our spans are around 200 feet, and we're in a heavy ice loading area. So in a heavy ice loading, heavy ice day, our fiber can sag as much as 2 feet on a 200-foot span. So let's say we have a clearance that we have to be at 15.9 or 15.5 feet over a road during heavy ice loading. That means that during the summer, during a normal day where there's no heavy ice, we actually got to be at 17.5 feet. Because we got to account for that 2 feet. So there's a lot of different requirements locally that you'll have to, and quite frankly, your engineering firm should know all this. Okay, any other questions? Did I catch them all? So I will be at the, I don't know what the plans are for next week, but I will also be joining next week. And again, I try to make myself as available as much as possible. You have my email address, and hopefully once you get, as Chris said, we're going to have a lot of fiber experts out at the boot camp that you're going to be able to ask a lot of these questions too.
Perfect. Well, I want to thank Esther and Bob again for the presentation today, and thank everybody for joining. We will continue these conversations, so if you have more questions, please hold them or email myself, and I'll make sure we queue them up for the next session or even on site at the boot camp to make sure you get the best out of all the virtual trainings and the in-person. So thank you again, and we'll see you next Friday.
Thank you, everyone. Take care.